Oh, the house was a mess, and it was all because Mrs. Bear sat around all day watching television and munching chocolates.
Athol, are you in this room?
I'm over in the corner watching the radio.
The narrator said you were watching television.
Television's busted. I'm watching radio.
KBYP, Saturday night, nothing on TV, so I want to show you these big 3 lies in amateur radio about antennas. And then I want to show you a cool experiment as proof. And the textbook de jour, which is a source as proof, University of Physics, 3rd edition, 64, Sears and Zemansky. You've got to get this book if you want to understand electrical physics. It's a fascinating book. Extremely well done. But on page 542, we have essence of Coulomb's law. Electrical charges opposing each other have a mechanical force in between. And that force F, just like in mechanics, is K, we don't care about. Q times Q prime, that's how much each of 2 opposing charges are. Q and Q prime are 2 different charges opposed by a distance. Like that. I just called them E. But the force is the product of the charges and the square of the radius between them. Critical point. These charges, which can be on an antenna wire and ground, have a force proportional to the square of the distance between them. When the electric field line is not moving, there's no magnetic field. When it is moving, then there's a magnetic field coming away from, let's say, the location of E prime is coming towards us off the paper. At no time, according to the amateur radio myth, do any of those things reflect. Fields do not reflect. What reflection is are the charges coming together. Maybe a field goes onto a piece of metal and induces charge, and that charge hits another charge, and energy is popped off at some distance like a cue ball. That's what constitutes reflection. But at no time in that wire above ground do those field lines reflect anywhere. They're 2 field lines trying to push the charges apart. The statement that antenna fields reflect off the ground and cut through the antenna again and cause antenna's impedance is a crock of lies that somebody has made up. Now, this relationship, force is proportional to the amount of both charges and the square of the radius, is critical in proving the big lie that 2 pieces of wire in line parallel to the ground is a dipole. It has nothing to do with dipole. Dipole refers to these 2 charges and how they couple with each other, and that's a charged dipole there. But that is not what's happening in the antenna. The second screamingly hysterical myth is that magically the wire is an open circuit at the end. And since there can be no current in an open circuit, the voltage between the wire and ground must be extremely high. That's easy to prove false because I took a field strength meter out, which they don't do. And I simply walked from the feed point out to the end of the wire, and I measured this kind of distribution of fields. Strongest in the middle, nothing at the ends. It was electrical field because I could hold the rod antenna by a piece of tape I put around it, and the reading went pretty much to 0. So that proves there's coupling between the wire through my body, or through the antenna of the meter, my body to ground. When the meter was in line between the wire and ground, the reading was max. When the meter was tilted, still pointing at the wire but tilted away, the reading went way down. That proves it's electrical field between the wire and ground. But the first part of the myth is that the end of the wire is an open circuit. It can't be because it's not a circuit at all. There's no circuit whatsoever. Circuit doesn't apply here. This is a transmission line. The only way current on that wire, which is what it really is charge is being transferred between electrons. There's not necessarily any electron motion. The electrons can take charge from photons being passed down the line. But that can be 0 at any point because of the nature of the driving wave, which is assuming a sine wave. When that sine wave crosses zero, then the current's zero. The voltage is also zero. So there's no such thing as zero current at the end and a high voltage. When there's energy there for a given power, then the voltage and current are everywhere in proportion. And in a matched transmission line, they're the same value all the way out. When the line's mismatched, when it looks reactive, there's a phase shift, but it's never the case where one is zero. Because if for a certain amount of power, if the current goes to zero, the voltage goes to infinity, and that cannot happen. What happens at the end of the wire is that this is not electrons moving. This is charges being passed from, to put it crudely, electrons orbiting around atoms. And the electrons don't move in a straight line, they move in a circle. Or there's two systems of thought. There's the shell method, and there's the orbital. At the end of the day, we can think of it the same thing. The electrons orbit. They don't just go in straight lines. But since the electrons are spinning, when their charge reaches the end of the wire, it can just as easily go a little bit sideways and then come back, unless there's another charge preventing it. So if the number of charges is relatively small, the energy can easily go to the end of the line and just turn around and go back the other way with no loss. So that is what constitutes reflection at the end of a wire or a transmission line. So simple measurements with a $5 meter proved that was completely false. And here's the big lie, the Hertzian dipole. The antenna is a dipole because it has oscillating charges by the Hertzian model of these charges oscillating. But notice the charges couple with each other through the center. When they're not in line, when there's an angle, that relation of charge squared over radius squared, and charge squared assumes they're both the same magnitude, is modified by the cosine of the angle. When the angle is 0, cos theta is 1, so it's maximum. When the charge moves, the field lines are weaker and weaker because the radius is going up. So the force decreases by dividing it by the change related to the square of the radius. It's a big drop. Rules for electrostatic fields in particular say that if there are two charges on those wires, it can't be a charge in between because there's no charge difference in a conductor. When I measured a real dipole with the field strength meter with the antenna pointing towards the wire, the reading was maximum. When I turned the meter sideways, the reading was nothing. So there are none of these imaginary dipole fields between the wires. I wanted to prove that because field strength meter, cheap piece of junk, it's not a great indication. And I was working with low power. So I did this experiment. I made me a dipole feed point of the same number 6 wire, and my DX list, my DXCC map, tied to a piece of string at the top of that wire, suspended from the ceiling, knowing good and well this is going to be a joke. Because while I was putting it up, I knew why this ain't going to work. There's a small gap, like in a dipole. It doesn't know where to focus. And I had a couple pieces of Litz wire soldered to it with banana plugs for the meter. And they're held together by thin pieces of fishing line, monofilament. Another piece of wire going towards the ground or the floor with nothing attached to the end. We got nothing to focus on. Let's put the DXCC chart up here. Now you can see the gap. So I connected the meter to it. It read 3.5 picofarad. I know good and well from the equations and the formula for a capacitor that there's not a prayer there's 3 picofarad between the ends of those wires. Because the field lines will tend to be straight between the faces. The faces of those wires form a parallel plate capacitance. Parallel plate capacitance is K, A squared over D. There's no area there. The distance is large. there ain't going to be but maybe a fraction of a picofarad there. But it read 3.5, and I knew that was wrong. So I reached down here, old radio man's trick. You want to change fields on something, touch it. Not if it's at 5 kV, but if you can safely touch it, touch it. I touched the wire down there, nothing happened. I touched the wire up there, it went crazy. It went to 11 picofarad. And it says, aha, I'm touching that. I'm a monstrous dielectric full of water. And that's doing something with the charges that are coming from the ceiling down that string. So to prove there's no capacitance between those two wires, I changed the spacing and nothing happened. Lo and behold, this experiment's in my physics book. If the charged body is a small sphere suspended by a thread from the laboratory ceiling, the negative charges on which its force lines terminate. So force lines come from the sphere. Two negative charges would be found on the walls, floor, or ceiling, or on other objects in the laboratory. That experiment proves, firstly, there's no capacitance between those wires. Now that's where the transmission line would be connected. It also proves there's charge coupling between the ceiling, which is the house, and the wire. And it's got to be obvious that this house is charged. Outside there's wind blowing. Of course, there's wind blowing in Ham Shack too, high. But this proves a critical point. And that proves where this idea of this dipole antenna is pure BS. Various books show these imaginary field configurations like between the wires or some nonsense like this. And I don't recall which book it is, shows some nonsense like this. Okay, from the viewpoint of energy from the transmission line being dropped on those two circles, which is a feed point, that energy has just touched the ends of those wires. There is no distance anywhere that comprises inductance, because inductance is a function of length. There is no capacitance there. If you're lucky, it might be 1/10 of a picofarad between those two wires. There is no capacitance there to accept any charge. Therefore, there's no charge coupled between those two wires. And that's a basic proof that if there's no charge coupled between the wires when they're that close, there's none coupled between them when it's even further away. And that's proven by this cosine relationship. As the angle increases, the angle basically between these two points is 0, so cos 1, but the angle from here to this surface of this conductor is effectively infinite. There's no coupling. So there is nothing at this feed point except an extremely small parasitic capacitance, maybe a 1/10 of a puff, maybe a couple tenths, for that line to couple into. And here's what proves my point and my experiments showing that these wires are transmission line segments coupling with the earth. Amazing how they mix the theories. Well, there's got to be reflection from the wire to the ground back up, but it's also a dipole, and that's simply meaningless garbage. If you take those two wires, which are the feed point of a dipole, that would be a dipole for, I don't know, 200 megahertz, whatever. If you take those wires and turn them sideways so they're parallel to the ceiling, it'll be a similar system to those two wires out there parallel to the ground and close enough to couple field to the ground. And there is the nature of this antenna. It is not a dipole. It is two end-fed segments that are coupling to the earth. And for a bonus topic, since data is cheap, here's one arm of a dipole. The circle on the right is a feed point. The slash line on the left is the end of the wire. At top right, that's 0 degrees of a sine wave that has traveled out to the end of the wire and back. So it's come from the bottom right, where it says 180, it's traveled to the left, reached the end of the wire, and reflected. So right there and then, this is the energy distribution on the wire. There's 0, there's 180, there's 90 at the end of the wire. So the wire is effectively here, between 90 and 0, 180. Now assume there's a sine wave. We don't care how much energy there is. We want to know how much is going out and back at any time. Let's call the energy a unit. Let's say that 90-degree point is 1 unit high. We don't care how many volts it is, doesn't matter. What causes antenna emission are charges going both directions on that wire that collide, and that throws energy off. And I have proof that actually happens as a result of the fields between the wire and ground. It doesn't happen directly from the charges, but that's another more complicated topic. But take your calculator with the sine function, and for these different degree angles, like in the very center, for the reflected wave, that center of that wire is at 45 degrees, and the incident wave at the bottom is 135. Flip it around backwards, doesn't make any difference, because both points are 45 degrees from each end. Now go halfway between the 90 and the midpoint, and make another mark, and that's half. That's half of 45, more than 45 to the left, and that's half of 45 less of 135 to the left. And for several points along that line, where those degree markings are lined up with equal spacing either side of 90, figure the sine for each of those angles, and you'll find that they're exactly the same value. What you'll also find is that the value of sine for 90 degrees there is 1. So if there's energy at the bottom of the wire just coming to that point, it's stopping and turning around. There's nothing happening at the end, because the energy is coming to the end of the wire and is effectively just flipping around backwards. So that there's nothing, I shouldn't use the word differential, but I will. There's nothing differential happening between the charges. It's all one charge at the end of the wire. It's just turning around directions. There's a maxima in the center, which is of the relation at the end of the wire at 90, it's 1. But at the center at 45 and 135, it's a square root of 2. And this is an interesting revelation if you'll sit down and draw this and calculate it. But the maximum is in the middle of the wire. And that agrees exactly with what I saw when I measured the fields with a cheap $5 field strength meter, a maximum right in the center. And not this mythical maximum at the end of the wire, which is pure BS. Now, assuming that there are charges of equal magnitude from the feed point all the way out to the left to the end of the wire that are, after the first 180-degree interval, are the same magnitude going opposite directions, and all those charges collide and throw energy off, then there's no energy left coming back to the feed point, and that's the definition of no reflected power. Change the length of that wire to 80 degrees. The midpoint is no longer 45 and 135. The overall length is 80 degrees, so from 0, top right, it's 40 in the middle, 80, coming back along the bottom, 120, and all you know what breaks loose. Now the charge distributions on top and bottom are not equal. And that, race fans, is the very definition of reflected power that makes it back to the feed point, and it's just that simple. I've never found that analysis anywhere. So anyone thinks they can disprove it, go for it. Have a PhD textbook reference. So unfortunately, I've run out of what I can tell you about antennas because what I'm studying is far beyond this and it goes into the quantum world, and I'm heading towards writing some papers to submit to IEEE. I'm working on 3 of them. So unfortunately, I can't talk about any of that because one of the conditions of publication is that you don't put it out anywhere for obvious reasons. So this is unfortunately coming to the end of what I can tell you about antennas. So I'll try to find some other cool stuff to talk about besides that. So there's pretty much everything you need to know about antennas. KBYP did it.